Hi everybody. I guess now you can also see me. You won't be able to see me for a long time because I will share my desktop instead and have more technical things. But it's very nice application. Nice to see the public people quite close to real life. So hopefully you also enjoy it. Okay, I will turn the camera off and start sharing my desktop. And I guess it is time to start with the first presentation after lunch. So hello everybody. Thank you for coming to this conference. Unfortunately, online. Hopefully next year we will be able to have a live one again. And thank you for coming to this presentation, Data Science with Power BI Desktop. Before I continue, of course, we have to mention our sponsors that helped and enabling this event. I am Dejan Sarka. I am pretty long in this area, 35 years. I've been data platform server or data SQL Server data platform MVP and MCT both for more than 20 years, authored, co-authored 19 books, many courses, and so on. So what I will talk in this presentation will be how do you do more advanced analysis with Power BI, mostly with Power BI Desktop. Of course, after I will also mention what happens after you deploy these things. And I will show you how you can use advanced analytics from many sources, starting with the good old analysis services, multidimensional data mining. And then I will mention that there are some analytical functions in some of the out-of-the-box visuals. There are some advanced visuals which already have data science algorithms implemented in the background. And then there are many ways how you can use both analytical, very popular analytical data science languages R and Python inside Power BI. You can use them as data sources, create the data, do the visualizations, and even do transformations inside Power Query. And then I will also show you how you can use Azure machine learning experiments or web services inside Power BI. And finally, I will also mention custom visuals. And let me go directly to demos. I have like one slide for each demo, but mostly...
Excuse me, Dejan.
Yes, please.
Nothing is visible on the screen. The screen is black.
Sorry, let me go back and check. Okay. And now it works. Right? Let me just... Yes,
yes, thank you.
Yeah, so good old reset, exit and come back, like always with Microsoft applications and Microsoft operating system works. Okay, so now we can continue. So I mentioned, let me go back just to see this agenda slide. So I will talk about using analysis services, data mining, some advanced analytics inside existing visuals, some advanced visuals that have data science algorithms behind, and then multiple ways how you can use R and Python inside Power BI, and how you can exploit Azure ML models inside Power BI and finish with custom visuals. So first, let me go directly to Visual Studio, and I created in analysis services, I created a mining model clustering mining model. I'm using Microsoft clustering, and let me show you algorithm parameters. I will enlarge this. So I'm checking whether there are 3 clusters, and my data I use is from the AdventureWorks DW 2017 demo database, DBOV target mail view. And I'm using a couple of clustering is undirected algorithm, so typically you don't have a predictable column. I'm using input columns, customer key, and then many input columns. But I have also a column, one, it doesn't matter which one I selected by buyer, which is input and predict. This is some specific thing in analysis services clustering. And I already deployed this model in analysis services, and now I can start exploring it and check. Darker color means more cases, so apparently cluster 3 has less cases than other clusters. But then I can check distribution of other variables inside clusters. For example, region Europe is typical for cluster 1. I can also check what favors cluster 1, what favors cluster 2, and try to analyze what this cluster means. Now I would like to get this analysis without these predefined visualizations that come with analysis services. I would just like to do this analysis inside Power BI desktop. So what I created, I deployed the model, and now I can browse the model. And I browse the model with a language called DMX, Data Mining Extensions. This is the language that is used in analysis services multidimensional for mining models. Here are my 3 clusters, and here are the distributions of input variables in these clusters. So for example, in cluster 1, bike buyer with value 1 is probability 49%, for 0, 51%. And I can try to get this data inside Power BI desktop. However, I cannot use this data directly because in DMX, what you see, this node distribution column, this is actually a nested table, and you cannot use a nested table inside Power BI. In DMX, we have keyword flattened. We could do this in a flattened way. And we can also assign cluster membership to source data or even to new data if I have the same variables. And to assign these clusters, I can use DMX prediction join. And in order to use DMX prediction join, at least one column must be predictable. That's why I selected bike buyer for predictable, but I'm actually joining using all columns, not just bike buyer, you see. And this way I can properly assign cluster membership to original data. This is simply DMX prediction query. And if I execute it, I get all of the original data plus cluster membership. And that's it. This is already prepared for Power BI. Now I can switch to Power BI desktop. Let me go to full screen mode and correct this. Come on, move. Okay. Don't jump, just move. Okay, and let me switch to Power Query. So I have already a data set called SSAS clustering. I have many demos, so I prepare things in advance. It would take me like 3-4 hours if I would do everything step by step. But what is the first step? So my source, let's see, first step here. So my source is analysis services. And this is my local analysis services, and the query is DMX query. You just have to...
Excuse me, I can see any changes. Is this only on me?
Speed up. So what I have shown so far was that you can do DMX query. Now you see DMX query in Management Studio. DMX query that joins a mining model with a prediction, DMX prediction join to some source data back to DBOV target mail view. So I got cluster membership together with source data. And now I can use this in my source query. So in my Power Query, I use the analysis services source and simply copied pasted this query. I just wanted to make a quick notice that when you connect to analysis services, either multidimensional or tabular, Power BI, Power Query asks you to write either MDX or DAX query. However, you can also write DMX query, although it's not mentioned, but you can write also DMX and simply works. Now, I'm sorry, I will try not to talk too fast now. I'm in a hurry, but makes no sense now to talk too fast, and I think you will not be able to understand anything. Anyway, here I have some visualizations. So I have my analysis services clustering model and data, and I'm checking, for example, what is the education level in this bar chart, what is the education level in different clusters. So I can try to understand what these clusters mean. Or with the donut chart, I am showing a region in clusters. Now, the next thing I said I will mention is this advanced analytics that is built in some of the visuals. So if I select one of the visuals, in this case, I selected the donut chart. I have here three possible tabs. One tab is where you select which columns you are using, then formatting, and then the third tab is analytics. And as you can see, donut chart has empty analytics tab. So let me go to bar chart. And when I select bar chart, analytics tab has some possibilities. You can add constant line, minimum line, maximum line, average line. I added, as you can see, median line. And I also added two additional lines, percentile lines on first and third percentile. And these are these three lines. So bar chart has already some nice analytics. However, bar chart is a starting point in this advanced analytics in Power BI visualizations. In my data set from this analysis services clustering, I also have two continuous variables, age and yearly income. And I'm showing their relationship in a scatter plot. And inside the scatter plot, I have also used age is on x-axis, yearly income is on y-axis, and I'm using coloring by cluster. So I can see pale blue is more in the bottom, so these are typically people with lower income. And orange, cluster 3, are apparently people with higher income but not too old. And the rest is darker blue is cluster 2. Now I have also two lines here, and let's see what these two lines mean if I go to Analytics tab. So the first line, the black line, is the trend line. So this is color black. So the lower line is the trend line. So apparently, the older you are, the higher the income is. And the red line is what is called ratio line. See, this is the red line. It splits the data into two halves. In the bottom right corner, we have older people. So age is more important, higher numbers. Top left, income is more important. Now there is another way how to do this kind of splitting. It's called symmetry shading. So you can shade this area based on either income or age. So let's do the symmetry shading. And what you can see is practically nothing happened. What is the problem? Symmetry shading now happened. Everything is shaded with a single color. So symmetry shading kind of doesn't work here. I have actually two colors selected. So it should be lower color also somehow available. I can even change the color to something more pale, so there is bigger difference. Still, nothing happened. Everything is shaded with upper shading color. What is the problem here? I will just delete this symmetry shading. Symmetry shading expects numbers on the same scale. And if you look at the X and Y axis, income is measured in $10,000s. So we have numbers like 50K, 100K, 150K, and age is measured in years. So we have ticks at 20, 40, 60, 80 years. So everything looks like overwhelmed by income. So there is something we need to do to improve this. Also, I am not buying, look at the black line, the trend line. This is actually linear regression line. I am not buying this, that the association between age and income is linear. This is purely based on my experience. But if you think also from real life, income goes up with age, and in some point, when you retire, for example, it starts to go down again. So apparently it's not completely linear relationship. We have some advanced options, even linear regression, but I am not satisfied yet. I will go to Transact SQL query and just show you that in my AdventureWorks DW database, I have also one view called time series. So I have aggregated sales quantity and amount over months. I have date index, time index over months. And I will use this data. This is data for 3 years. We have 36 rows. I will use this data in my Power BI desktop. So this is data, this is my time series data. Source is now SQL Server. I just again copied and pasted this query, right? And I have time series data. I am using this time series data for line chart. Line chart has also some powerful visual advanced analytics. So you see, I have sales, and I have sales until December 2013. This is the last known value. And if I click Advanced Analytics part, I can add in line chart, I can add forecast. So I'm adding next 6 months, next 6 points. And I'm also showing that 95% confidence interval. So with 95% confidence, we can expect that the actual value will be forecasted plus minus confidence interval. With 1 out of 20 times, the actual value will be even out of the confidence interval. It looks very nice. The algorithm behind this visualization, the algorithm used is ARIMA, Autoregressive Integrated Moving Average. And I would say it looks impressive, right? However, I am not too satisfied. You know how forecasting works? You use current value and then you forecast first next value for the next time point. And then you use this value in the next time point to forecast the value in 2 time points from now. And then you use 2 forecasted values for 3 times time points from now. And I would expect that 95% confidence interval wouldn't be so thick immediately. It should go more like this. You see, more like this. Initially should be narrower and then thicker. So still I'm not too happy with this. Looks nice. And my bet is that this is due to the fact that there are really quick changes that then have huge influence even on the forecasted values in very near future. And again, from experience, what I would do in this example, I would use, instead of actual values, I would probably prefer to use moving averages to smooth the actual line, and then I should get better forecasts. So again, something to improve very, very soon. Now I will just switch to slides to see where I am. So this is what we already saw. And we mentioned that in scatter chart and line chart, we have some really more advanced analytics. Inside Power BI desktop, we have two really advanced visualizations. The composition tree, you kind of build how decision was made to, let's say, do something, buy a bike, not buy a bike, manually, step by step. And key influencers, you can analyze which input variables have the biggest impact on the target variable. These are the key influencers. And here is again, behind the stage, a very advanced algorithm used. It is logistic regression. And of course, I prepared already these two visualizations. And you see, this is key influencer visualization. Let me select it. So we will be able. So I am trying now to analyze clusters based on region, education, number cars owned, and commute distance. And let's see what has the biggest impact on cluster 1. Here we see number of cars owned, 1.13 and lower. This is the biggest impact, so 1 or 0. You cannot own 1.13 car. And mostly from Europe, don't commute far, and so on. And I can check what are biggest influence, which variables have the biggest influence on cluster 2. Please note that now this refresh takes some time, not only because of this software, but because Power BI Desktop is actually doing this calculation. And here we can immediately see that also for cluster 2, this is big distinction between cluster 1 and cluster 2. Cluster 2 are apparently people with more cars, also commute distance 10 plus miles or 5 to 10 miles, and so on. This is one advanced visualization. The second, very nice, is the composition tree. So the composition tree, in this case, let me again select it to see which variables I am using. So I'm analyzing bike buyer, explained by region, cluster name, occupation, number, cars owned, and commute distance. And I can do this expansion step by step. This is again interactive visualization. And in every step, I can check how to expand. I can go to high value, low value, or to specific variables. So in this case, when I came bike buyer from North America to cluster 3 to management, then I go to commute distance and see that even in the original, before this last split, I had very few bike buyers. This blue part of the line is very low. After I did the split, I still found a very important group of people that are still good bike buyers, although originally they were not so important. Now, if anybody is as long as me in this area, you might remember the OLAP client ProClarity, Gnosis ProClarity. This was the one that invented the composition tree, and this company was acquired by Microsoft around 2005, I think. And it's still the same decomposition tree here around. Now I mentioned that I can use R and Python in many places. You can use it as source, you can use it in transformations and for visualizations. But Power BI desktop is not running R or Python code. You must have R and Python engine installed on your computer where you use it. And this in Power BI desktop, you just point where this engine is. And then another option is what development environment do you prefer to use for R and Python. This is useful for visualizations only. And once you set up these two things, you can start using R and Python. Now, the next question is what happens with this R and Python code when you deploy Power BI file somewhere? Well, there are two options, right? Power BI service or Power BI report server locally. At this time, Power BI report server doesn't support R or Python code. So locally, you are limited to show this in desktop only. Power BI service supports both R and Python, however, with some limitations. You have to realize that the Python and R engine for Power BI service is maintained by Microsoft. And you cannot just use any library. If you check Power BI documentation, you have a list of supported libraries for both languages. For Python, this is not such a big deal because you don't have so many additional libraries, and all of the most popular are there. For R, there are still, I don't know, more than 100 supported libraries, all of the most popular. But if you consider that R has altogether more than 13,000 available libraries, then you have to take care which libraries you use in your code before you use functions from those libraries in Power BI desktop, because it could happen that you wouldn't be able to deploy this anywhere. Also, of course, you don't install libraries from Power BI desktop, so you should install them in advance with R or Python. And then inside Power BI desktop, you load those libraries you need to memory. Another thing, now Power BI works with tables. This is classical table, tabular format. We have rows, we have columns. R is statistical language, starts with statistics, data science oriented language, and statistics was developed more on matrices. Now R introduced an object which is called data frame. It looks like a table, it has columns, it has rows. However, it's not table in relational sense, because it is something in between matrix and relational table. It looks like a table. You can refer to data with data frame name, column name, but you can also refer to data positionally. For example, you can say, give me value from the 7th row, 3rd column. Also, the order of rows is preserved. Now, when you exchange data anyhow with Power BI, when you use R, for example, as a data source, you have to return a data frame, and then Power BI desktop converts this to table. When you use R for transformation, you are already inside Power Query, so you have a table. A table is converted to data frame, then you do whatever you do with R, and then you return a data frame which is converted to table. When you work with R visualizations, you have tables, right? You are already now in Power Pivot, let's say, in this visualization part. You done your transformation, so you have tables. Again, this R visualization changes the selected data from tabular to data frame format, and then you can use R to work on it. What about Python? Completely the same, because for all data science part, Python simply copied the data frame logic from R. So we have completely the same object. Also, the name is the same, data frame. So you work in R and Python with data frames. And then you can use R and Python, as I said, for source, for visualizations, and for transformations. And let me show you, I will really, since we spent so much time, I will not go into all of the details. But what I will use R for example, I will read the data. I have here an iris dataset. This is demo dataset that exists in R. And we have sepal length, sepal width, petal length, petal width, and species, which is character column, so we can analyze over species different numerical values of petal length, petal width, sepal width. And I will just unpivot this before I can use it in Power BI desktops. I will have just species variable value. This will be simpler way to use it. And for visualizations, this is a nice R visualization using ggplot, very popular R library. So I'm analyzing this four continuous variables over different species. And I would like to get this violin plot also in Power BI desktop. I can also read some CSV file, and for example, in this case, I exported the target view for quicker work, and I will create another plot with scatter plot and add also marginal distribution. This is then so-called joint plot. And I am adding on scatter plot also linear line, but also what is called lowest line that shows the connection between age and income, also with polynomial regression. And you see blue line clearly shows that with age, the income goes up until some point and then it starts going down. And here we have also marginal distribution. So another nice chart. I can do very similar things with Python, and I will not go through Python code. I will just show it to you. I will upload everything. So I have also iris dataset from Python from R transferred to Python, and also, for example, I can calculate moving averages with Python, and I also have some advanced visualizations. Let me go now to Power BI desktop, and first go to Power Query and show you our source. So our source is extremely simple. I just loaded library reshape2, which brings me function melt, which is R unpivot, and then I can use this as a source. I return the data frame, then I expanded tables, and then I just edit index. Index just sequential number. Power BI desktop is very keen on grouping data. And if you don't have anything unique, it's sometimes hard to get back unique rows. And I did something similar for Python. So I have another data frame from Python. And again, we have Python source iris dataset. It's a little bit more code, but it shouldn't mislead you. In general, you don't need more code with Python than with R, approximately the same. Just this iris dataset is somehow weirdly stored in Python, but I don't want to go there in details. Now, let me go back to my SSAS clustering. Remember, this is the data frame that I got, not data frame, table that I got with DMX. Remember DMX flattened query? And now I have it inside Power BI. And now I can use here in transform part, I can use run R or run Python script. So I actually used R script. And what this R script does, look this, it uses a scale function on age and yearly income. And then it outputs back a data frame, scale function, and it adds two new variables, scaled income and scaled age. Now I have both variables on the same scale. Remember, symmetry shading didn't work well because of different scales. What does it mean, scaling in this case? This function does z-score transformation. So from every value subtracts mean value, and then this subtraction divides with standard deviation of the variable. So after the scaling, the scaled variable has mean at 0 and standard deviation at 1. And these are my scaled, let's see. So I have, besides original values, I have age scaled and income scaled, and you can immediately see that these are numbers that fluctuate around 0. And one more thing, time series, remember moving averages. And I read time series directly from SQL Server, and then I used Python script. And in this case, I used Python to add moving average, so average over last 3 values with the rolling function. This is part of the pandas package. Of course, this is for demo purposes. You know that in Transact SQL, this data comes from SQL Server. In Transact SQL, we can also use window aggregate functions. Average over last 3 values is very simple, done also in SQL Server. So I could do this already in source query, but then it wouldn't be so fun, and Python wouldn't show its strength. And finally, let me go back to Power BI desktop and Python visuals. I will open this page. So what I get, I have analyzed this iris dataset with R violin plot. And you see what I'm using is iris med R dataset and visualization. I selected all 4 columns. Index, remember index I added in Power Query, species, value, and variable. And what did my visualization is created a data frame. You see the R function data.frame. It created a data frame called dataset. And what it says in the first command, first row, remove duplicated rows. That's why I needed to add an index. Otherwise, I would finish with only a few rows and would get weird results. The other part is just ggplot, copied from RStudio, and I get my great violin plot. And the same thing is for Python. Python has a nice visualization swarm plot, also very intuitive, and I'm using, let's see, what is called the swarm plot function from the Seaborn package, and I'm getting this swarm plot, right? Also, Python is the same thing, creating a data frame out of selected columns and deleting duplicates. I also added R joint plot, and in this joint plot, this is again R visualization, right? The same thing we saw in RStudio. And in this joint plot, I can also now see that the association between age and yearly income is not linear, it is more polynomial. Also with bigger age, the confidence, 95% confidence level becomes quite quite wide. And finally, remember income and age scatter plot. Now, when I use the scaled versions of income and age, this is already symmetry shading with this nice Benetton pink and yellow colors. So with scaled versions, you can see that symmetry shading suddenly makes a lot of sense as well. And you see where are older people, where age is more important, and where income is more important. So with scaled versions, we also get rid of another problem. Now, we have only a few minutes left, but I also really speed up this quite a lot. So how can you include Azure Machine Learning in your Power BI desktop? I will switch now to my Azure ML Studio. I have some experiments or let's say created mining models. So I have now bias analysis of what has influence on buying a byte. And I will not go into details of this, of course, Azure ML, but you can create web service. So out of a model you can create a web service, and then you can test it. You can test it in Excel with new data, or if I click the link here for batch execution, there you get generated code how to use this web service on batch of data. And you see that the code is generated for C#, the code is generated for Python, and the code is generated also for R. Now I could use directly this code. I have R and Python engine available. I could use directly this code and start using web service in my Power BI desktop. However, Azure ML is a step behind the development. There is a nice library called Azure ML already available for R, and I am actually using this library. So basically, this is library called Azure ML. You have to take care about case sensitivity. These are just these GUIDs to get to the web service and service name, and there is simply one function, consume, and you feed it with service name, okay, workspace ID, service name, and this is the data you will add predictions to. And then you can, this will take some time, so I already executed this in advance, and then you get predictions back together with the original data. So I also decided to use this version for Azure ML. Oh, by the way, I simply forgot on this tab, on this page. Remember when I said that I will use moving averages for forecasting? You can immediately see that now I got this what I wanted. 95% confidence interval is narrow for the first predictions and then linearly grows, not like becomes very, very wide immediately. So at least first predictions are much better than they were. And here I have analysis of predicted values for bike buyer, so over commute distance. So I have like and for 3 regions, like in Europe with higher commute distance, bike buying habits to buy bike goes quickly down, while in Pacific they still go up. And how did I get this data? Let me go to Power Query. So this is the data frame I created with R. So I created data frame. So this is using Azure ML library. Actually, the code that Azure ML creates is way too complex. And of course, you cannot execute C# code inside Power BI desktop. You could use R or Python, but with this newer Azure ML library, also this task is extremely simple. And finally, last thing, we are at the end, right? But I have only one page left. Of course, there are hundreds of custom visualizations. Some are pretty advanced. So in this case, I'm using decision trees visualization. And this decision trees visualization is now analyzing what influences cluster membership. So it's kind of automatic decomposition tree. So I'm analyzing cluster membership in a decision tree. And you know that you can get visualizations here. You just click three dots and say get more visuals. If you already downloaded, you can import it from a file. I just want to show you one more thing. We are at the end of the presentation. Just one more thing which is important for this custom visuals. You have to know how they are created. So it simply means you have to read the documentation for the visual. Otherwise, you might get some surprises. Okay, where is this window now? Here it is. So let's go and advanced analytics. And I will search for decision. Where is decision trees? It's not. Okay, let's see all. Decision tree, here it is. Okay. Anyway, here is the description. Show more. If you worked with R, you would already know what kind of libraries. This comes from R. This is, you see, using packages rpart, rpartplot, rcolorbrewer. So, and these are the versions. And if you want to support it, R versions. If you want that this visualization works for you, you must have one of these R versions and this libraries installed, rpart, rpartplot, rcolorbrewer. That's why it is important to, of course, read the documentation. And other custom visuals have other rules. Now I'm already 3 minutes over the time, so I will just go back to, I don't know where, to Zoom or to Avatarland. Anyway, is there any question? Is Hubert still with us? So Hubert.
Of course, I'm standing by you all the time.
I see you. Thank you very much for your support. I really sped up. I don't want to use the time for the next speaker, but maybe we have time for one question. But I will also come at 6 to the QA session at the end of the day in the auditorium.
Okay, thank you very much, Dejan.